Hello, this is my talk about how to build your own Ruby VM on the microcontroller. Last year, I find a mini arcade game station based on a microcontroller, and I think I can run the Ruby on it because it is run the MicroPython on it. So when I try to find some mruby solution for it, but there are no existing project support for it. So I try to build my own Ruby VM on it. Okay, I'm Auto and I come from Taiwan. This is my ID in the programming community. And I usually working on the web and the game. So my favorite language is Ruby, so I usually try to run Ruby on anything if I can or I know how to run Ruby on it. And I'm working for the 5 Ruby in Taiwan. We provide the consulting and the software development for our customers, and we use the Ruby and Ruby on Rails for our customers to build their business. And we have a lot of customers from the worldwide, from Japan, America, and Taiwan or Singapore. And in last year, I co-working with my friend to build a game project. This game is a car game, and the server is right in Ruby, but the client side is use the Flash. So we have to rewrite it to HTML5 or use the Unity to rewrite this game. And this game is open source on the GitHub because the company in Japan is no longer running. So we use the source code and we try to rerunning this game. Okay, so let's back to our project. And this project is starting for my game company because I want to build some special present for our player. And this is just trying to build some small kit on microcontroller. Okay, so many people think build a language programming language VM is very hard, and I think in Taiwan many people also agree it, but it is actually very hard. Yeah. So my answer is yes, because we need to learn many things to build a programming language. But in some case, for example, we have a mruby. The source code is less than other languages, so we can read it easier. So this is the reason I think we can do it more easier. So I started trying by myself. So this is my first time to try it, and I did not know how to start it because I had read about have the source code of the Ruby, but I still have no idea because it is have a less code than the C Ruby, but it still have a lot code and a lot of logic. And the books did not tell you how to build a very small programming language VM. So I find another project is the mruby L1 VM. Yeah, this is because I try to run our game from Flash and convert it to HTML5, and I try to let our player can use the mruby to write some script to extend our game. But it is very hard, and I did not successful to build this program. But when I research for it, I find this project. This is a very small mruby VM, and it can run on the web. And this VM only have 1,000 lines code, so it make everyone very easy to read it. and you did not need to spend a lot of time to know everything, because the code path of mruby is already right inside this source code. So let's talk about how does it work. Yeah. As my knowledge, depending on my knowledge, I think programming language VM is a loop, and it will read each OP code, and depending on the OP code, define some behavior. So we start our mruby program and read some bytecode from the mruby compiler compiles binary, and we find the OP code inside it and do something. And next, if the OP code tells us we can exist our program, so we stop it. If OP code tells us we still have something have to process, we go back to and read next OP code and continue to do something and until we finish our program. So if you try to read the mruby source code, you may find a nrbvnsq method, and this method uses some macros to define it, but the main part is a loop, and this loop will read OP code, and inside this loop we have a large condition to check each OP code and find the current method have to run on this OP code, and we will execute it to do something. And this is the code path if we want to build a language VM. So the first question is how to read the IR from mruby binary. So we can use the mruby compiler and enable the verbose features. So when we enable it, we try to compile a Ruby code. You will see the detail about the compiler generated data. And the most important part is this section because it shows the OP code inside it. And it is very helpful for us to find which OP code we have to implement and to run to this Ruby file. So for example, this Ruby file is just a one-line code because we press a hello world. So for the next, we have to talk about the mruby binary struct. And each mruby binary struct we have a header and some IR inside. And if you enable the debug mode, you will have some debug information inside it. But I think the mruby 3 will remove some data from the header, so you may need to check the source code about the header size. So in most cases in mruby 2, the header is 34 bytes. So we did not care about the header because it provides some metadata inside it. And we did not need to extract it, and we still can run our virtual machine. So we can directly skip it. And the next part is the IR. The IR will provide the information about the OP code and some data about the local variables or the data inside your program. So the IR still have a header, and the header will provide the local variables and the register. This is a temporary variable you need to run your code, and some code block inside it. This is the your Meso defined block inside it, so you need it. And the last part is the ISEC. Yeah, this means your OP code inside it. So in the IR, when we read the header, we will start to read the ISEC. So when we start read ISEC, we will get our first OP code. So we can simply create a loop and try to move the pointer to next, and we will get a OP code. If you put empty Ruby file, you can easier get a OP nub or OP return or OP stop, and you can stop your program. Okay, so next we try to build a 1+1 Ruby code, and we will implement it. So when we use the mruby compiler to compile it, we will see they have 4 OP code we have to implement. The first is the load integer operation. We can use it to load some integer. And the next is the add operation. We use it to add some number. And the return and stop, we will return our value and stop this program. This is the sample code, but it is a little long, so you can scan the QR code to find my gigs. Okay, so in this sample code, we implement the load integer feature to support from 0 to 9. And we also implement the add. And because we did not wrap the mruby variable, so we can directly get the integer from our register and add it. After we get the return, we simply print the result. And when we reach the stop, we can simply stop our loop and exit our program. And in this case, we have finished our first mruby visual machine. So I think this is very easier for each one because you did not need to learn how to write a compiler, because we already have a mruby compiler, and we can just focus on how to make a visual machine work. And then the next section is how to read the data in our IR, because we already have some OP code, but we may save some string or symbols inside it. Or we have some bug or some method inside our Ruby code. So we have to read it and use it in our loop. So this is a very simple source code from mruby L1 VM. I have modified it, but you can see the data is each session. So in mruby L1 VM, they will find the data inside it and skip the session they did not to read about it. So when you find the data, your pointer will stop at it and return it. So this is the method the mruby L1 VM to find the data. In the mruby source code, they will save in a hash to ensure they can faster get the data. But in microcontroller, I think some microcontroller did not have enough memory to save a lot of things. So you may want to save more memory to run your program. So you may spend the time to find the data instead of catch the data pointer position. So the next one is called Meso. We have two ways to call Meso. The first way is define a method inside Ruby and we call it. And another way is we define a method in C and we call a C method. Okay, so when we try to call a method, mruby compiler will save the method name inside the symbols. So the first step we have to find a symbol name in the method name inside the symbols data. And when we find the method, if we define it inside the Ruby, you have to find a sub-IR inside it, because your method body will inside the sub-IR to define how to run it. So let me show the compiler result. We can define a add method and just simple just run add two numbers, and when we call it, they will return the same data, same as the 1 plus 1. But when we compile it, you can find the output is more than we showed before, because we have two parts. The first part is our main program, and this program shows we have a OP code to define a method, and this OP code defines method will point to another method address, and this address is our method body, and then this method body is new IR for inside our program, and this program have the detailed logic for our customized method. And after we find it, we can call it, and we will use our method reference to run our add method. But to implement this feature, we have spent a lot of time, so I will skip for this part, and we can go to the next part is how to define a C method. This is very easy in this case. So I create another way in C add method. This method did not define in Ruby, so the Ruby will try to use another way to execute it. When we compile it, we can see it's just called the OP send, and it will try to find a method. If we did not define it, and your visual machine cannot find it, so we can do some easy way to make it works. Okay, so this still is a long path, and I only show the major part inside it. When we receive the OP send, we can find it in the Ruby defined method, or we can just compare it and find a C method. In this case, I will try to find a C method. How to get the symbol I put inside my piece, so you can open the QR code to find it. And in this case, when we get the function name, we can simply use the string compare to check it. Is it the C add? If it is a C add, we can do some logic inside our C program and save the result to the register, and your Ruby program will get the data. So if we did not find any method, we can put an error message and exit this loop. In the mruby implement, they will save the error into the exception data. So you can find mruby have a mruby state. But in our sample visual machine, we did not keep any state. So it cannot for beautiful complete logic, but we can use it to learn how to build your first visual machine in very simple way. So I have a small demo to show my progress when I try to run it on the microcontroller. So this is a mini archive station I buy from the internet, and it have a microcontroller did not support by any Ruby project. So I have to build my own Ruby visual machine and run on it. This microcontroller support Arduino, so I connect some Arduino API and use the Arduino API to render something. So in my Ruby code, I build some C function, and I can use the Ruby to call it. I also implement some feature like the loop to make I can create some simple animation on it. Okay, so let's play it. Okay, you can see the text is throwing on the screen. Yeah, this logic is implemented inside the Ruby code, and I compile it and concat the data with my VM, and I save it into the microcontroller and make it work. So I also have a series article right in Chinese about this project. So you can scan the left QR code for it. And the series article also have some prototype code. So you can read the right QR code to find my code on GitHub. So, and the next, I think I will try to build a full-featured visual machine in the future. But currently, I'm trying to use mruby and build some IoT device for my plans. Yeah, so I did not continue work for it because I have a lot of things to work. But I think this is very interesting experience for build your own Ruby visual machine. Okay, thanks. This is my talk about how to build your first Ruby visual machine. I think this is very easy and you can try it because it's not it is not hard for our imagine. So I suggest you just start for it, and maybe you can build your own version and use and run the Ruby on anything you want to run on it.